All right, we're back for week 9 of the GDAX project using Kotlin and architecture components. Right on. And right away, looking at the comments, looks like Anderson asks if he can ask a question. Go ahead. I'm reading the comments, and I will do my best to answer whatever questions you have. All right, so let's take a look at the project we're going to be working on this week. And all of these weeks. It is, already got it up and running, this, which is this page. And what this is, and it wants me to refresh the page here, is a place where people can buy and sell Ethereum, which is a a cryptocurrency for dollars. And so we have people who want to sell it up here, people who want to buy it down here, and then any trades that happen over here, as well as a price chart to show what the price has done over the past however long. And what we're trying to do is basically just show all of this data in an app. So GDAX, which is associated with Coinbase, they have a really nice API and a WebSocket and just all sorts of stuff to make pulling in every single piece of data on this page something that we can do pretty easily. Now that doesn't mean it's easy to make the app. You know, there's a lot of moving pieces, but it does have all the data, and this keeps us with a nice small scope of a project, so there's not too many things that we can throw into this project that aren't on this page, for example. So we're trying to make this, and if you go to this website on an Android phone, I think eventually that's what we're going to end up trying to make exactly. So that's what we're trying to do here, and if we look at the project real quick, right now we have the trade history section done, so we can see this top order here matches this top order right here, and you can see there's a little bit of a difference in our bars over here on the left. So I think our bar maxes out at 80, whereas this 127 makes this red bar barely even pop out from the side. So we went with a little more visual pizzazz over here on the left. All right, and so is this be live? There we go. Cool. And so what we're trying to do this week is pull in the order book data, and the order book data is what's on right here. So we want to pull in and get this section done. So we've already got this section on the right completed, but we still need to get this section on the left. And also, if I'm not easy to hear, or if you can't read something on the screen, just let me know. We can bump everything up. There's tons of settings for all that. But so what we want to do is pull in this data over here, and how you do it is there's an API that they give us, and it tells us how to do that right here. It tells us how to create the real-time order book. So we've already done steps 1 and 2, which is send a subscribe message for the product of interest and queue any messages received over the WebSocket stream. So we've got a WebSocket set up that's pulling in all these different types of messages, and we need to use those messages to create the orders. But what we don't have is the orders that were already there on the books. So while we're pulling in all the new information, we don't have anything that already existed. So we need to find a way to combine those two to create one order book. And I think a good test for that would be to see if we can consistently print out the best bid and the best ask. So this, if we can print out whatever the lowest thing is here and the highest thing is here, I think that'd be a good test to show that we've accomplished building the order book correctly. And what's going to make building the order book so complicated is that in the web sockets, from the WebSocket, we get 5 different types of messages that are important to us. So we get open messages, done messages, match messages, and change messages. Oh, and received messages. And these messages tell us different things about orders. So received means that we've received an order. Open means that we've received an order, but it hasn't been completely filled yet. A done means that the order is off the books. And a match means that a trade happened. So our trade history table just shows matched orders. So that was a pretty easy one to set up. And then, of course, people can change their order. So if you say you want to buy 100 Ethereum at a price of $50, you could change that to be, no, I just meant 50 Ethereum at a price of $50. And so we have to take care of managing all of that in real time if we're going to have any hope of keeping an order book to match the actual order book. But step 1 is to pull in the existing order book using a REST call. So that's what we're going to start with. And first, let me see if there's any questions here. Cool. So we're going to try and pull in all that data with a REST call, and we've already got it somewhat done. So right here, we're using the fuel library to grab that data and just print it out. But the issue with this is that right now we really just want to test that we can use the REST API. We would just want to set it up and make sure that we can use it and kind of get all the work done before we plug it into our app. You know, running an Android app takes a minute or two every time you run the app. So it's really not, you don't want to do things like this where you have to actually start the activity to test anything, because it just takes forever to start the activity. So what we want to do is we want to find a way to get this into a test. Now, this isn't going to be a test in the sense that we can, you know, we're really going to be testing anything yet. We might in the future, but right now we want to end a test, and specifically a test, not an Android test. An Android test is a test that does require the Android device to run. So if it was an Android test, it wouldn't be any faster for us to run through this code than it would be otherwise. But by putting it in a test down here, it's essentially like we're writing just a Java program. And so we can test much quicker. Unfortunately, we're going to get some issues with this. So let's try and run this. And we were getting issues last week with this, and I wasn't able to figure it out, which is why we put it into the activity. But I've found a solution that'll work. But first, I want to run through what the error is and why we have to have that solution. And it is going to build to run the test, which is a little annoying. But I think it only builds once. Okay, so here we get an error that says method getMainLooper and Android OS looper is not mocked. And what that's telling us is that somewhere in this code, it's calling something from the Android system. That thing that we don't want to have running right now, that we don't want to use for our tests. And so that's a problem. And what we can do to fix it, or what I thought we could do to fix it but doesn't work, is over here in our build.gradle file, we are importing the fuel library for Android. And if we go to the fuel library, we can find that there are a few different imports you can use. So instead of using the Android one, why don't we use the one for the JVM? So we grab this JVM guy, paste it in here, change the version to the latest version, which can I Alt-Enter that? Sure can. And then we can change this to, instead of compile, be test compile. Then we can sync the project. And I thought this would have worked, but if we run the project from here, it still won't work, which is super annoying because apparently I can't figure out how to get something to compile only for a test. So what I think happens is that when we run this, and let's try to run that test again so we can make sure that that does happen. So run the test again, and this time I think we'll get the same error. And I tested this out a bunch of different ways. It doesn't matter if you put the test compile above this or below it or whatever, it'll still use this one for some reason. And that's why we're getting this problem. So I'm not sure how you can specify separate. You should be able to. I'm almost positive it's possible. I thought it was test compile, but it doesn't seem to be test compile, as this compile is overriding it. But what we can do to fix this is just, instead of using this Android version of the library, we can just use the JVM one. And that should be just fine. So we'll pull that out, and then instead of being test compile, we'll just compile. And actually, let's leave that comment at the end, because that will help us if we're ever looking at the documentation later. And then if we sync this and try and run the test again, the test should work. All right, there we go. So that is how we can get this to work in a test environment instead of actually requiring us to run the app. However, it does do that. That was awesome. That came in right as I said, however. All right, how do I grab you? Come on, there we go. Okay, so what we have now is a little issue where this response JSON is from that Android library that we got rid of. So let's get rid of that because we can't use it anymore. And that's going to give us a little problem down here where we are using the response JSON. And to fix that, instead of using response JSON, we can just use something else. So let's see what's available. Response string sounds fine. And it'll still pull in this request response result trio of variables. However, now the data object, instead of being a JSON object, is a string. So instead of doing data.object, we first need to transform this string into a JSON object, which is actually pretty easy. So we just go JSON object, and then end parentheses. Actually, let's just do one open parenthesis so we can see the options. And we can see that one of the options, guess I shouldn't have moved the cursor, is JSON as a string. So we just pass in that string, close it, then we take that, and it's already a JSON object, so we can get rid of that. And then that should work just fine. But also, we don't want this code. And so this code right here, this X function, I mean, it just gets called right here at the beginning of onCreate. We're only using this to test right now, and this isn't where we want our test. And since we figured out the other test, let's come in here, cut out this stuff. Oops, and we need that bracket too. So get X and the endpoint, and that should leave no errors in here other than the two that are not really errors. So just for getting back on that, when you set, for these two, when you set an ID for a view, you set it to an integer, and that's what it is. So this is totally legit, and it runs clearly, but it still gives us this little squiggly and says it expects it to be of the form r.id.something and be a constant somewhere, but that's okay. This is fine and works perfectly. Okay, so instead of this, let's just paste in what we just got over the endpoint. And then I guess we can just put this inside the test, right like that. And then this should print out everything we were printing before, but we should be able to run it without using an Android device, which should make this run much, much quicker. And it's still going to build, so I'm going to see if there's any questions. Cool. All right, so that's still needs to build, but it should run and print out all the bids and asks that are already existing on the order books. And then hopefully, since it's already built, right, so that we need to talk about. This code right here is asynchronous, using this http get.response string. This is asynchronous code. So this code is going to get hit, and then we're immediately going to assert true, and that's it. The function stops. We're not going to get any of our log messages, which actually we wouldn't get anyway, right? Because those require the Android system. So I think we'd want to, all right, let's do this real quick. We'll put in a print line there, and because pretty sure this doesn't run asynchronously, but we should get actual prints in here just to make sure. Because again, this E method here actually ends up calling log.e, and since we're not using Android for our tests, I don't think those would print here. Okay, so there we go. We close this file. We have this test print that should have printed but did not print. So this didn't get called, and it didn't get called because http get.response string is an asynchronous call, and so it's just gonna hit this, move immediately to assert true, and then end the function. That's it. None of this is going to get to happen because it's too slow. And to fix that, we need this to be a synchronous call or a blocking call, and basically wait for this to finish before moving on. And we can do that using the fuel library pretty easily, actually. Somewhere down here. Blocking mode. So instead of response string and then a function after response string, which is what we have, so this is a function that we're passing in to the response string method, instead of doing that, we just set it equal to this. So I'm just going to copy that. And also just look at how awful that Java code is. That is awful. So paste that here. And then we want to HTTP GET on our endpoint. Oops. On our endpoint. And then we want to get these guys. And I think we just get rid of this and that. That should do it, right? All right, let's see. So now, and these E's I still don't think will log anything. So we're just looking for data and test, but it should block this time. All right, there we go. Oh, what? That's frustrating. So we did print our test object out, and that's good, which means that it ran completely. However, it's telling us that the method that JSON object get, and get is going to be this. So at Kotlin, these two brackets, this is actually operator overloading for the get function. So it should be that line, right? Yeah. And it's telling us that get is not mocked. I'm not sure why we need to mock that. That is not, should not be from Android. Well, I guess let's look at the import. Yeah, org.json.json object. So let's see. And that seems like something other people would have hit. Really? That's part of the Android framework? Oh, that's painful. No, there's a way to unit test JSON for sure. Java can obviously do JSON parsing. All right, let's try this solution. Though that's probably a super old version. Org JSON, and that is what we're using, right? Yep. And that's going to take a second to sync. So yeah, if you were ever wondering why testing on Android is so complicated and difficult, it's because a lot of the methods that you need for testing and a lot of the objects required for testing exist on the device. They don't actually exist in the Android SDK. And so you get a lot of method not mocked errors. Oh, look at that, nice. Did that work? Yeah. Yeah, cool. It's going to tell us method parse color is not mocked. And is that because somehow with the E we're using parse color? That's probably what it is. So let's get rid of our E's there now because we know those are wrong. And we can middle mouse click and drag, oops. Middle mouse click, drag, cover that guy up, and just do it like that. And then I think this will do it because without the E there, we're not hitting that extensions file or exts file that does use parse color. So that's where that parse color was coming from. Interesting that it got compiled that way. And there we go. Okay, so let's refresh real quick. This line right here makes it, and let's add a comment. Is it JSON? Yeah, JSON object is from Android. This lets us use JSON object and tests. Cool. And those are, yep. All right. And that's actually not something we need to sync, but whatever. Okay, so let me see if there's any questions on that real quick, because that was all a little confusing and whatnot. And nope, not taking a call right now. Hey, how to tackle screen size orientation. So we're not quite to that part yet. So I don't think our app handles that at all, actually. Let's find out. Or rather, it will, but it's not built for it. Yeah. So yeah, that actually works pretty well. So we've somewhat tackled it just by having a UI that I think is percentage based. And so this is a constraint layout. Each one of these rows is a constraint layout inside a recycler view. And so I think by setting these to have certain weights, maybe, I forget what the word is exactly in constraint layout, but that's going to make them be nice and spaced out here instead of being all scrunched over to the left or all scrunched over to the right. So we've somewhat handled that, but not explicitly. It was just a happy accident. Oh, let's look back at that. GDAX has stopped. Neat. What happened? And let's close QuickTime also. So logcat, talk to me. And this, so see that here we're not on the right emulator, so we're not going to see anything down here. And sometimes when you run the emulator and then you close it and then you open another one, you get this going on, which is just useless. I don't know why they show this disconnected stuff. I guess maybe if you were looking for errors after the device had been closed, that would be useful. But, and there's our errors that we log using the E method. And are we filtering by something then? Yes. Still annoying, nothing there, but, and can we, all right, let's scroll to the bottom. There's some blue code. Oh, interesting. That is, make sure the cursor is initialized correctly before accessing data from it. This shouldn't be possible. We didn't write any of this code. This code was all generated for us by the Room API, which is an alpha, so we're gonna give it a break on that one. Let's just hope, we're gonna assume that this is a Room error, maybe a bug or something, just because that is still an alpha, but that we didn't write this code. We did write in our data folder here, we did write the open orders DAO to specify the functions or the database, so this stands for database access object. So this is sort of where you define all of your database access functions. And what's really cool about this is that if you make an error in here, let's see if this will work. If we do that, will it catch that? I think it catches that. So that's one of the advertised advantages of using Room, is that it will catch your little syntax errors like that. But back to the error, this is something we created. There we go. So cool that it catches that without you even needing to run it and do anything. All right, so it caught our error, super cool. But again, we just specify this, it's just an interface. There's, it creates its own implementation of this interface behind the scenes. And since the error was in the implementation that Android created for us based on this interface, I'm not sure how we could have caused that error, though who knows. All right, so we got a weird error in our project, but it works. And we got this all set up and printed out, right? Yep. So let's print out the best bid now, and the best ask. So bids are first, and then ask, which they are in order, aren't they? So the bids will be going down from the top bid to the lowest. We've got 265, and then all the way down here, we have 199.61. And this goes up to 201.64. And something to call out is by passing in level equals 2, we're only going to get 50 bids. Just for testing purposes. When we want this app to work actually, we'll be passing in level equals 3, which will give us all the bids and asks. But there is a warning in the docs about abusing that and getting too many So pulling in all of the bids and asks too many times, they'll stop your access to the API. So just for testing, we're just going to leave it at 2 for now, and which means we're only going to get the 50 best bids and asks. Okay, so we've got the sequence and the data, which we break apart to create the sequence bids and asks. So we don't really need to print the data. And the sequence is important because this sequence number tells us it's the timestamp for when the order book snapshot was taken. So when we get messages like done order or match order, see, these all have a sequence. And that tells us where this thing happened. And everything that happens gets the next number in the sequence. And so that's how we can kind of mesh things together. So what this is telling us is that we want to get sequences after this number. And anything that comes before this is already reflected in the orders that we've gotten. So we can ignore anything before that number. Anything after that number we would need to deal with. So say we got a change order with a sequence after this, then we would need to find that order using the order ID and our orders, or bids and asks rather, and then update it with the new size and the old size and the price and whatever, whatever changed here. And this is giving us a bid. So this isn't giving us all the orders either, is it? Let's see. This is FUSD book. So let's look at the API and see what we're getting for that. API requests. Orders. Okay, so place a new order. Nope. So what we're looking for here is, the issue I'm thinking that I see is that we don't have any data in here for what orders these are. So of course that data we're going to have from the WebSocket, which is, so any new orders that come in, we're going to have all of the data possible. We're going to have it as a received order, and then if it's not immediately filled, we'll have it as an open order. And then when it gets matched, it'll be a matched and a done order. And if it changes, we'll have a change order. So we'll have all of those rows in our database to keep everything straight for the orders that are coming in. But for the orders that aren't in already, that are already on the books, we kind of need to know which orders those are, so that if we get a done order or a match order, we can cross them off the books. However, looking at our data here, we don't have that. There's no order IDs here. It looks like we've got the price, the size, so people want to buy 20.53 Ethereums, and I'm guessing this 3 number is that there's 3 orders at this price. That's my guess. But we need to figure out something better. So let's see, we are looking at, back to our test, the products. So perhaps we need to look at orders. So let's go back to our, what would it be, source of truth here. So was it in the WebSocket section? We're looking for that bit that tells us how to create the real-time order book. There we go. Make a REST request for the order book. So I think that's the step we're not doing. I think by pulling in products and looking at the book like this, maybe we're doing it wrong. Let's try a level 3. And can we control F level 3 here? Level 3 is non-aggregated and returns the entire book. Okay, so yep, that is the problem, unfortunately, because that's going to make, right, yeah, here's the warning. Abuse of level 3 via polling will cause your access to be limited or blocked. So we want to do this infrequently. However, it looks like level 3 is the only one that's going to give us an order ID. So we do need to do level 3 instead of level 2. So there's no getting around that. And I was right. That was the number of orders at that price. So that's cool. But we need level 3. So let's do level 3 and then see what we got. So level 3. We get bids, and let's actually, we'll print the bids, and then let's print out the asks each on a new line. So asks dot for, oh, is JSON array not a real array? To array, oh, that's kind of frustrating. So it gets it as a JSON array. Dot weird. Put, wow, lots of puts there. JSON object, a string. Huh, so this is not an array in any sort of Kotlin sense of the word, or a list, or anything like that. So I guess we can do, oh, this could be an interesting way to do it. 0 to asks dot size, length. Okay, this could work. Dot map. Wait, that's a range, right? We can map that. Yep, dot map to, and then it will just print it for each one. Does that work? Print line, asks it. Okay, I think that works. I'm somewhat unsure, but I feel like that works. So sometimes when you make a loop in Kotlin, it'll tell you that you can refactor it to this different way of specifying a range first and then like mapping off the range, which is super cool. But I think more confusing than using a for each loop. But I guess sometimes you can't use a for each loop, so I hope that works. And there's the sequence and some bids and JSON array not found, huh? I wonder, well, whatever, it printed most of everything we wanted to look at, so yeah, success. Who cares about that error? Wow, look at, this is a big order book. This is why they don't want you to pull down the whole thing. So look at this. This is people selling it for $2,000. It's at $200 right now. These orders are not getting filled anytime soon. And yet we have to pull them in because we need the order IDs. Yikes. Okay, so let's get this set up and then we'll try to run that not more than once every 5 minutes or so. Although polling would be like once every 30 seconds, so I don't think we're going to get anywhere close to polling it. But if we scroll up to the top here, we can see that 254 is the best ask. So it's been a couple seconds since we ran that, but it should still be pretty close. 254. Okay, it is still the best ask. Is it really the same price too? 8. Nope. There we go. Okay, well, it was there for a second. You all saw it. All right, so we've got the order IDs, or we've got the bids and the asks, all the order IDs. We can start keeping track of the order book. So we might even want to make like an order book object just to help keep things straight here. So I guess real quick, I'm just going to check and see if there's any questions, concerns, or anything. Yeah, we do need a course for developing Android apps in Kotlin. There is one, though it assumes you know Java first, but you might be able to take it without Java, without knowing Java that well. It's a pretty cool course to make a solitaire app, a headless solitaire app, and then in the second, there's a second course that follows after that. You build the front end or the UI for the solitaire app using the Anko library, which we use in this project a lot too. And we're working on some more beginner Kotlin stuff as well, but that at least has been done for a while. So if you're looking for learning Kotlin from building a cool solitaire app, we offer that, and it's super cool. One of my favorite courses that we have. All right, so we have an order book. Let's make a play at an order book object here. Actually, are we gonna be able to use WebSocket in our test? That would be so cool. So if we could do, no, there's no way, because you're gonna have to use room. I wonder if they have anything about testing room. Android unit test room. Was that something? Nope, not testing on an Android device. So I don't think we'll be able to pull in the, let's close that down, that guy. We won't be able to pull in the WebSocket into our test. So what would be really cool and nice is if we could set up a test to just use the database side of things and set everything up and just make sure everything's working without doing any of the UI stuff. Unfortunately, Room is very tightly coupled with the Android framework because it's part of the Android framework, so I don't think we're going to be able to test quite that well. But what we can do is, now that we've got that, let's create an order book object, file class, and order book. And just for fun, let's make it a singleton. So object, and now it's a singleton. And what that means is that the order book object exists and there can only ever be one of them, ever. There's just one, it's the only order book, that's all there is. That's what singleton means. But what's cool about singletons and Kotlin is you just declare them with the object keyword, and from there you can just use them wherever you want. So for example, here we are in nav drawer. We are inside the init function, which is essentially the constructor if you happen to need a constructor. And we can just type order book, and it's just right there. We just have it. But actually, let's put in a val x equals 2, so you can just access, and we were in nav drawer, order book dot x. So you can just access pieces of it anywhere. Really simple, really cool to use. So that'll make it so that we're able to create our order book easily and maintain it. And if we ever do something more than Ethereum in US dollars, then we would want to create it as a class instead of as a singleton. But since we're only doing Ethereum to US dollars right now, we can do it as a singleton. That is cool. So let's get a val of bids, and boy, we're going to need a bid object. So data class bid, and let's get another one. Actually, should we have a second one for ask? It's a little repetitive. Maybe order. Do we have an order class somewhere? I don't think we do, actually. So I guess we can do that here. So order book, data class, order. And then it will have a val of price, a val of size, and a val of order ID. And what are you telling me? Oh, you need to have a type, that's right. So price is going to be a float. And in Kotlin, all types are objects. There's no primitives, so that's why we're using capitals. Also a float, and the order ID string, right? Yeah, looks like a hex string down there, so string. And then let's make order ID the first parameter, or last, I guess. They've done it last. We can keep it that way. They did price, size, order ID. Yep, we can do that too. Okay, so that's order. And does this class already exist, or what's it telling us? Redeclaration. Okay, but so if that's a redeclaration, let's comment it out. And then here, let's do val bids. And just to get me a code block I can use, I'm just going to do that. And then order. There we go. So Command B. Oops. That was backspace twice. Is bid size float. Okay, so where are you used? That's the only usage? It's an open orders fragment. What, is it not used right here? An orders fragment. Now, is there an open order class as well? Let's see. So if we do, yeah, there is. Oh, right, there's a data class of open orders. So we've got a little namespace collision here. So this should be, all right, let's start out here. We want to use order for the order book. So that is set in stone. I want order right here. I want this word to be order. But fortunately, we also have open order as one of our database access, or one of the tables in our database, which is a little confusing because then we have this open, or this order class here, which let's just rename this to, so Shift F6 doesn't work because got Mac stuff going on. Refactor, rename, and I'm going to call this, let's go with, we'll just call it an open order. Kind of hate that, but I don't want to be dealing with that right now. So, and I do want this to be called order. So now we've got order here, which is what we want. Okay, so it's got price, size, order ID, cool. Then we've got bids, which is a mutable list of order equals mutable list of, because in Kotlin you cannot ever initialize something to nothing. You have to initialize it to something. And actually we don't need bids and asks, or well, we can have bids and asks. I think that's fine still. So the question there is, do we have bids and asks, or do we have orders and then a specification in here to tell us if it's bids and asks? Which would mean we could use the other order class actually. So then in here we could do open order, and some of these could have a null order ID if you don't have it. So where do we create open orders? Now, do we have an open order? It dot. So in here, do we have order ID? We do. Oh, that's cool. Okay, so this works super well. Back to open orders adapter. Let's close this order class. We don't want that. Then we're gonna change that other one back to order. So we're gonna change this back to order, but we're gonna give it an order ID column. Name to order, and is bid, size, price, and then val order ID string. And then where we set it, so Command B to pull this list up, and we can see where we set it equal to anything. Right here, it's going to give us an error, and we can also pass in it dot order ID. Okay, so now we've got our our order object, and we can use it in here. Awesome, and we can just have orders, orderbook.orders, and that'll be that. Great. Which, you know, we could end up doing this just as, we don't even need a class necessarily. It could, if it ends up being something simple, we might just get rid of the class, but I was thinking we might need some methods in here. So we'll keep it as a class for now, technically a singleton to be a little more specific, but okay, we've got that. So now when we load the app, we want to pull that data in using the REST API. We want to pull it in one time. So like when we rotate the app, we don't want it to pull in again. So I think we'll have to use a view model for that. And let me see if there's any questions before I keep going. Awesome. So we want to pull in the data that we've got here. So we can start with this. And we won't necessarily want it to block, or will we? It's sort of important to get that data. Maybe we'll have a block. Okay, so we're gonna have to pull that data in. It's gonna have to go into like a view model like this. Open orders. Or rather, we could just add them all to open orders. That's what they are. Oh, that's an easy way to do it. Yeah, let's do it that way. Okay, so if we pull everything in as an open order, or we get all our data, so all this stuff, which these are open orders, we can put them straight into the open orders table, and then we can still just have the open orders table as our source of truth for our view that we're looking at in the Android app. The only problem with that is that if we put these orders in, then while this is loading, our WebSocket's going to be spun up as well. And we might get the WebSocket to pull in a piece of data that we have already inserted into the orders table, or vice versa. The WebSocket might put something in the orders table, and then the HTTP request finishes and loads in an order that we just got via the WebSocket, which will give us a primary key error on the order ID. Presumably, let's make sure those are set up as primary keys, because that would be a bad error to have. That'd be really tough to find. Data, open order. Primary key of sequence. Yeah, that should work too. So yeah, because each thing will have a different sequence. And yeah, so we just got to check, make sure that we're not inserting anything into our tables that's already there. Okay, so let's see what happens. So main activity, we need to load that data just one time. How do we load it just the one time? Open orders view model. Which means, okay, so it is .load open orders sync. Oh, and it gives us our open orders by sequence, which is not necessarily what we want. And in the open orders table, we have side, so we are able to figure out which side it is. Okay, so I think the first step we want to do is we want to find a way to get, or rather to load that data, this data right here from the test, these bids and asks from the order book that already exists. We want to load that when the activity starts. So it needs to be somewhere in onCreate. But what we don't happen is for that to be called every time we rotate the app, which is a little more difficult. So let's try something a little different. I'm gonna come out here to the app class. Now, that strikes me, so saying it out loud, that feels like something that we do in a view model. However, I'm not really sure how I would do that in a view model, or if we do it separately. So we've already got this open orders view model, and this is sort of relating to getting the data from, I feel like, the WebSocket, but I guess it's really just getting it from the database. So maybe as long as we populate the data in the database, I don't know. I'm not entirely sure how to do it with a view model. I would feel safer doing it in the app class, so that's what we're going to try here. So let's take this, and I'm going to grab this guy, actually all of this. Well, and we're going to need the endpoint too, but we can grab that in a second. And on create, we're going to do download, or rather, download order book. That works. Download order book. And so this app on create function is only called when the app starts. So it's not going to be called every time you rotate the app, or really, I mean, it's only going to be called when the app starts. And if you force close your app and then reopen it, or you leave your app through the back button and it actually gets shut, then it'll actually call this onCreate method again. But otherwise, this onCreate method is only getting called once per app. So we can download the order book here and do all this fun stuff. Endpoint, so we're gonna have to pull in our endpoint. Which we can have private to the function. Then get bids and asks, which we don't really need, except for that it is split into bids and asks already, so we do kind of need to do it that way. And then we can use E now. So we will log an error there, and I just get my line back like that. Okay, and then don't need to, let's not print any of this stuff anymore. Though, what do those look like again? Let's look at the run tab. So these look like price as a string, size as a string, order ID as a string. And that's for each one. And we split them out like this. So yeah, I guess we can just loop through both of these because they're the same stuff, right? Oh no, it's slightly different. That's right, because one of them's gonna have a side of sell and another one's gonna have a side of buy. Okay, so bids, asks. Let's get, there's the asks that we've got. Let's do the same thing with bids. Do this. And I guess the error is pretty clear that it'd be to length -1. That's how indices work usually. So that should fix that. We'll use bids here. And then DB exists. That's awesome. So if we come into data and the parser, actually is the parser not in data? That's parser. There we go. So we need to grab some open orders because these are all open orders. Open message, so we can pretend that we received them as an open message, which is cool. However, some of these we can't fill in. Actually, we can fill in most of them though. Oops, let's go here and then back in the app. And since we already have access to DB right here, or really right there, and it will exist because it does exist before we call download order book, then right here, or rather inside each of these functions, okay, and sequence is sequence, that shouldn't be any error. Required int found any, so JSON, we can just do this like as int, I think. But you could also do it as JSON, I think, .get int and pass in sequence. Yeah, but we don't need to do it that way. We can just cast it to an int. Both are fine. All right, now we've got sequence. We've got, why would you pass in open? Type, yeah, I guess that is open for an open order. Time, what does that want? We don't really need the time. We're not displaying the time orders were entered, so we can leave that empty. Then for order ID, this is going to be, now actually if we print that, how would we print off one of these things? So we get it to print that, so which is still an array, so I guess we'd access it with like a 0, 1, 2, 3 operator. Asks it, does this, are you happy if I do that? No, you are not. Asks it dot, oh, that's kind of frustrating. What is, so then get JSON array, then for each JSON array, it is a JSON array, so So if we print bids up here, we get string, string, string. And very clearly those are in an array, but we can't access them as an array. That seems strange. It dot nothing. There's just nothing we can do to that. What are you? As JSON object? Huh. Okay, so let's do this. Asks dot get JSON array at index 0. And let's print that. And that should print the price for each one. And then we should, so I think that's the solution. We can run that real quick. We haven't ran it in a while. I don't think we're anywhere close to abusing the polling of level 3. Oh, right. Can't run our test if the code doesn't compile. Oh, and let's not do that at all, because we don't want to hit that twice. Guess while it's building, check if there's any questions. Cool, cool. And it's still building just for the test. Yikes. That's a really long build. So anywho, we are an app. Still building. Build successful. Test ran. Print me off a bunch of prices. I'm just curious if they're going to be in quotes. JSON array cannot be cast to J. Oh, dang it. Okay, cool. It's not in quotes. That's what we needed to know. So that will get us numbers and floats, and yep, can't do that. That's true. Okay, so we've got that all sorted out. Now let's come back in here, uncomment some stuff. And then we can pass in order ID, which I guess, can you split it? So it would be bids dot get JSON array at index of it, which is just the number and the range that we're going through. So it'll be 0 up into the length of the bids minus 1. So we're just looping through all the indices of the bids array and then getting the array at the index of that array. So it's an array within an array. And then we get that as the price. So val price equals that, val size equals that, and then we also have order ID, which I'm not sure why I've used an underscore there, but I have. And then that stays as 0. And then we have order ID, price, and this is going to be as string, as float, and as float. And then this is size for right there. I guess we can rename that to remaining size. Oh, it doesn't matter. Size will keep this all on the page so we can read it. That's nice. And then side is, I think, bid. I'm not sure. Let's find out. So we can find out. It's in the docs here. Down under WebSocket and the messages section, it would be an open order message that we're trying to emulate. So what we're doing is we're pulling in the order book, so all the orders that already existed, and we're just going to pretend that we got those all as open messages right at the beginning of the app, and that'll keep it kind of simple to maintain. and that when we want to show open orders, we just pull out all the open orders from the open orders table. So, and side looks like sell or buy. So this is a bid. So I would think that would be a buy side, but I somehow remember those being kind of different. So Control F, or rather Control Shift F to search the whole project. I want to see if I've used a buy somewhere else. So here, and the open orders, if its side is buy, then it is bid. So buy for bid. Got it. That's what I thought it was, but just for some reason thought it might have been something else. Okay, so we got buy. And then this can be null. So instead of this is here, this is referring to this companion object, which I'd not like it to. So let's do tempdb, 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 and now it refers to this database, which cannot be null through the magic of lazy evaluating. So what this does is it's not going to figure out the value of database until it has been accessed. And so its first access is now going to be here, which is in the download order book function, which is after tempdb has been created. So it'll access db for the first time here and set it equal to tempdb, which it asserts is not null, and it will not be null because we set it right before we call this function. So we could just do that. And then we can do the same thing down here, which is really making me want to set these up as one array instead of two arrays. So gotta be a way to do that. So asks, 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 open orders, open, and then this would be sell. Okay, so this works, but I don't like it. Val orders equal asks dot so those are JSON arrays. That's a little trickier to put together, I think. So I'm trying to think if there's a way that we can basically just combine the bids and asks while setting an extra property for the bids to buy, an extra property of the asks to sell, so that we can only have one loop here instead of two loops, because this is a little repetitive. I mean, this is the same code. I mean, we could pull it into a function. That might be the way to go, but let me just play around with this for a second. We got bids, which doesn't really give us much. Yeah, I guess we can just do it as a function. So private fun, add open order, and then it will take n a JSON array. So orders JSON array, and then n here, it's just going to do this code. And of our orders instead of asks. Oh, and it looks like we need to pass in a sequence too. So let's do that. Sequence, which should be like a long. Could just be an int. Okay, it is an int. I thought they were big enough to be long, so maybe I'm wrong. Okay, and then we got that. So then we just call add open orders on bids and Control D for asks. What are you complaining about? How's that not a JSON array? Oh, we need to pass in the sequence. Sequence, and then we can get rid of this code. That's nice. And then this is still blocking right now, which I don't think we want. We don't, yeah, right. Because it would block to download the whole order book before we even continue creating the app. Yeah, so this would stop the app and you'd look at like a blank screen with no layout. So you wouldn't even get to, here where we create the layout. So there'd be nothing on the screen for the whole time it's taking to load the order book. And God forbid you don't have internet. So we don't want this to block. We want this to be asynchronous. So we need to get this back to this format. It is like this, and then it was, let's find out what it was. Those three parameters, request, response, result. And yep, except it will want another bracket now. All right, and let's log a download order book message so we can keep track of how many times we've downloaded the order book. Ideally, it should be 1 every time we run the app, because again, we don't want to abuse this API or they'll shut us off. So definitely don't run this like every 30 seconds. Every 5 minutes, probably fine. Okay, we're gonna add those to our open orders DAO. Okay, so got all that set up, pulling into the open orders DAO. Then we're gonna get the WebSocket set up right here, and that's going to start pulling in all the new information. So let's add a new function to our open orders DAO. And did we even use this? No, we didn't. So let's just get rid of that for now. And in the open orders DAO, let's add a get best by function at query select star from open orders where side equals by, and that's going to be, you can escape the quotes like that, so where side equals by, and order by price descending. So it's going to show the highest prices first. And then this is going to be fun, get best by, and it's going to return a list of open orders. Okay, and when that runs at the beginning of if we run that right here in onCreate, that should give us the best by. db dot open orders DAO dot get best by dot for each it, and that'll print it out. And we can even add best by in front of it, and maybe even a little colon. And so let's see how close that gets us. Or if we get an error, we might get an error. We've done a lot of programming. All right, get the emulator up, check if there's any questions here for a second. Cool, cool. Emulator still thinking about running. Project is almost done building there. Still working. It'll get there. All right, it says the project was done. There we go. We got an error. Uh-oh. Let me hit pause on that. Don't want that taking up CPU time from the emulator. All right, let's check it out. We go to logcat and aha. cannot access a database on main thread. Okay, fine. So for that error, you do this. You do thread, open bracket, close bracket, and you put it around it. And now it's on a new thread. Yay! And we're going to need to be able to check our best bid. And see, this is why we like to do the testing without Android devices. Pure Java or pure Kotlin testing is the way to go for testing. You don't have to wait a minute or so between each run. Not sure how we got an order started. Okay, trade history starts by clearing the page, so it's not unusual for it to say nothing. However, order book, there's still shows something. And let's actually, we were gonna look at the logcat for our best buy. What's our best buy? There's a lot of best buys. How are there so many best buys? Oh, wait a minute. There is just one. It's the top one. So 201.28, and we're a few seconds behind. But yeah, that is still the best buy. And with a size of 11.7 at the moment. But it looks like it got some help in the meantime. Cool. So that looks good, I think. Okay, so let's look back at this open orders DAO. We got selected all the buys, but didn't really give us that many buys. So let's do, right, because if we pulled in that asynchronous stuff, we should have a lot more buys from when we opened the HTTP page. So let's do this. We can pull this thread. So we can put this into a while true, which, so I mean, we're gonna have to force close the app at this point, but that's fine. We can do a thread.sleep for 1,000. And instead of printing all of the best buys, let's just print the first one, get best buy 0. So we can set this to val best buys equals that, and then what we're going to do is print, so e, and we're going to print size, and we'll call it, then you need the brackets when you need to access the property of something in a string template, so best buys dot size. And then we also want to include the actual best buy. So we'll do comma, best buy, and we'll set that equal to, and we need the brackets again, best buys, and this is going to be the first one, since we have ordered those by price. And yep, thread.sleep 1,000. So we'll print that every second, and what we should see is that we'll have some buys in here from the WebSocket. So we should have some from that. And maybe the size of this will be like 50 or, you know, however many buys can come in and the seconds it takes our app to start up. But then hopefully once this finishes loading and loads all the buys, so even people who've said, I'll buy a ton at 10 cents, then it'll come back up and we'll see, you know, a much bigger number for that. So let's see if that works. I hope it does. All right. All right, that finished building. And there's the trade history. So it ran, checking logcat here. Yep, there we got 2, 4, 13, 19, 88, 105, 110. Not really sure that it's getting imported. Oh, looks like we got somebody at the door. So I was kind of hoping for a bigger jump here, somewhere that it would jump from, you know, somewhere where we had clearly imported that data, but we got loaded trade history. So let's get some more logs in that. So download order book. Did we log download order book actually? Let's search for that. DOWN. No, it doesn't look like it. Okay, so let's find out how that wasn't called. All right, let's go to the app. Actually, we can stop it right here. This button down here on the left kills it because we do have an infinite loop there. So that is no bueno. Okay, so why has this not ran? Scroll up to the top. Oh, no, it did run. Okay, good. Download order book. And we can add open orders. So let's adding open orders, num orders is orders.length or size length. And then that should be enough. I don't want to put a log statement in here because if there's a bunch of them, that would be too many. But we should also put a log statement here to make sure we get this returning something. So order book retrieved. I don't know why I'm using caps, probably just because I've been writing some SQL. Okay, so that should give us some more log statements to figure out what's going on with those open orders, because we presumably pulling in the order book should have a ton of open orders. Oh, wait, I see it. Stop. Okay, it's right here. This is the problem. We have set this to cell, and it needs to be not cell. It needs to be, I guess we have to pass that in as an argument, don't we? So let's do it. So we need to add sequence. Let's make that the first one. That makes sense to me. So side string. And so this is going to be by. And this is going to be cell. All right, so copy paste strikes again. It does that. Though I think that was an excellent show of how I feel like most errors are typos or copy and paste errors or other such things. It's almost makes you feel stupid, but it is easier to fix than an actual error. Okay, so we should see all of these print statements still run, except for this time. I think we'll see a lot more orders than 2, 4, 13, 19, 25, 30. I mean, there'll be a bigger jump. That's what we're looking for, because we want to see where we got the package of loaders, where we got the mother load coming in from the HTTP call. All right, we running? Nope, we have stopped. What did we do? We did this. Aha, what have I done? Index of 0. Best buys returned. There were no buys yet? Okay, maybe we need to sleep first. there should be buys in the order book. Wait, it printed one and then it stopped. That doesn't make sense. So that's more like what we were expecting right there, the size 466. So that, you know, it went, there was no 1, there was no 2, it just went straight to 466, which means that it loaded the order book like we wanted it to, which is super good. Did you fail again? Let's find out. Yep, sure did. And was this the same 21? Yeah, that's the same error. And is it after it even pulled it in again too? Download order book. Error right there. Order book retrieved. So it was before the order book was retrieved again. All right, let's make it 10 seconds. No, that should be too many. 5 should be fine. 10 seconds is kind of a long time to wait for your log messages to come through, especially when we're trying to make sure that it is pulling in the actual order book in its entirety and not just a small section of it. So assuming that we've got all the open orders now put in the order book, the next step is to make sure that we're not double putting in any orders. So if we've got to get those sequence numbers ironed out, as well as we don't want to, actually, where did that go? These guys, the like done orders and matched orders, we need to start removing things from the open order table. Which, do we do that? Let's see, where do we delete these? Yeah, we only do that in the beginning where we clear the database when they open the app for the first time, which actually happens there. That's not good. Let's put that in the app class. So we were clearing the database every time in onCreate, which was fine when we were testing things, but ultimately we just want to clear once when the app is created. So let's bring that here. Clears clear database, and then great. So we'll clear database first thing first when we run the app, and then we will get on with our lives. And that'll make sure that we're not clearing it every time we rotate the app, which is pretty good. We don't want to do that. Okay, so we got that 5 seconds figure. Let's look at the log cat. We should have something to look at because it ran. We just saw it. Okay, Best Buy, 25, 48, 73, 110. Number of orders, 25,089 orders. You know, that's a lot of orders. And for this to tell us there's only 706 buy orders out there, that just doesn't sound right, does it? 706, 83. No, that doesn't. I feel like we're not doing it right there. Let's change this function call to something else. And instead of getting the Best Buy, let's try to get all. Sure. Get all. And get all should return everything. Yeah. Even more than just the buys. And it should be more than, like, it should be strictly greater than the number we have here. Because if these are all getting inserted into the open orders table, and that's, you know, 25,000 things, we should have more than that, because we're gonna see 9. How's that 9? Order book retrieved, adding open orders, order book retrieved again? Wait a minute. What? Download order book is called one time. And yet we have order book retrieved twice. Control Shift F to let's see if there's order book. There is only one of these, and somehow it's being called twice. Interesting. Did I accidentally call it down here or something? Adding open orders, that many. db open orders DAO dot insert. That should do it. Open orders DAO. Insert. Yep. Inserts an open order. Don't need that. Need that guy open. Or you open. And when we do it with the message parser, I believe we insert it the same way. So there's nothing, I don't think there's anything fancy going on here. Read open message. So we get the open message, we call the order stall DAO, and we insert it. And that's it. There's no, you don't have to commit. You don't have to anything. All right, what are we doing wrong? Let's pull app over here. I feel like it's the most senior of things here, so I'll put it on the left. We get db.openordersDAO. It must be that something in here is getting this exception. What? Yeah, that's my guess. How are we getting this exception? Oh boy. It's from the app class, so it's in here that we're failing to convert something to a float. So it's presumably one of these two. String cannot be cast to float. Okay. So float dot, do we have a method to, so I'm gonna Control Shift F float to see if there's a place in this project where we have converted a float. Oh wow, that is not helpful at all. So let's go to Chrome and search for Kotlin and string to float, and we should get the answer. To float, is that really it? I was gonna try that, but I didn't think that would be it. All right, so that, and we're down here, dot, string, so dot toString. So this is gonna be an any, which is like an object in Java, it could be whatever. Yeah, so we can do it as string, I think. And then we'd have to do it to float, so that would make us need to put brackets or parentheses around that whole thing. So let's just do toString. And then dot to float. Okay. Okay, maybe that will fix our error. So what we're trying to get rid of is this error here. Which wait, that's getting called with our E function. How am I logging an error? Where is that being called? Okay, so that ran. Yes. And logcat says we can click this button to jump to the bottom. 65, 105, SQL. Yep, okay, so we did think we were going to get one of these errors. That's cool. And we stopped getting the other errors. So The sequence stuff is a concern though. So actually, we could make this block again. Because what's happening is while this is downloading, right here, while this is downloading, the WebSocket, I think, is getting spun up and pulling in a piece of data that we then get a second time from this, except for we only get one sequence from this. So what you want to do is have this be the source of truth and then have the WebSocket data sort of supplement this data. But we're getting this second, which gives us some issues here. And it'd be a lot easier if we got this first. So let's just try to get this first, and then we can, if it works, we can see how we like that as a solution, because it's going to block, and I'll show you what that means in just a second. So what we want to do is get val and parentheses and equals, and then pull these guys into the parentheses, and then get rid of this bracket arrow, put in those guys, get rid of this one, and then shift tab this to line it up right. And then now this, instead of waiting for it to finish, will block. So our code is going to block right here. So will block for, well, I guess just will block, or blocking would work. Blocking. So it's going to wait a second before it runs that. Let's see what that means. So here, once Gradle is done building, it should show us a white screen. That's my guess. Until the data's been loaded. Which would be okay. I think that would be okay if we showed an actual loading screen, because we do need this to load. Okay, so did it block or not? Nothing's happening there, so maybe it did. Let's see what we got down here. Network on main thread exception. Okay, I guess we can't block. That's kind of frustrating. I want that to block. And how are these getting logged anyway? Oh, I guess it's right here, huh? Yeah. Okay. And so first I'm just going to make this stand out a little more so we can see the errors that are coming from this message. There we go. So that'll be clear that that is bad. So we're doing networking on the main thread now, which is what I wanted to do, but it's not going to let me. Okay, fine. We'll go back to not blocking, which is the right way to do it, I think. But, you know, so put this back in. We're going to E error and then the error, which put a $sign in front of it to make it print the thing inside of a string. That's called string templates in Kotlin. Okay, so now it's not going to block. We can make the maybe we can make the WebSocket. Yeah, that's what we should do. We should not start the WebSocket until here. So main activity. Oh, but we've got it all nicely set up as a lifecycle observer even, which is really cool. That gives us this ability. So basically this is the code that we would put in the onDestroy method, but because this is a lifecycle observer, basically means we can pull out anything that needs to go in the lifecycle method. We can pull it out of the activity and put it inside its own class, which is really nice. And so here's the WebSocket where we send that message to tell it what data to give us back. And then whenever we get a message back, we pass it to our message parser class, which is this guy. And what he does is, depending on what message type it is, it reads that message and inserts that message into the appropriate database So it's not doing any of the handling. So like if there's a done order or a matched order, we don't remove it from the open orders yet. We still have to do that step, but we do keep all of the messages so far, which is, I guess, good. Though maybe we don't need to keep them. As long as we delete them. That's something we can get to in a little later. But okay, we've got this. We don't need to print all of this really, but this doesn't fail that frequently, so we'll just minimize that. Get our client, get our request. Yep, this is the WebSocket now. When we create the WebSocket, when does it start getting the data? Probably on open here. Listener, which is a WebSocket, gets client. So presumably when we create the new WebSocket is when it starts here. It's because it does this stuff. I mean, it's going to create this variable when the WebSocket starts. So, and the WebSocket, what do you require to be created? Nothing, right? Do you require a context in here even? No, not really. So, and then we create it when we start the app, and that would be a good way to do it too. So if we have the WebSocket isn't going to be running here when you're not in the app, which is really cool. So it's going to be created here and started and on create, and then it's going to get shut down and on destroy. So really simple setup of our WebSocket. It works really nicely. The only problem is that our HTTP data comes in after some of the WebSocket data. So ideally, we can postpone the WebSocket starting until after, and what is the error in here for? Until after this has done its business. Because we want to get this order book downloaded, and we want to get these orders added to the open orders DAO, and then we want to start doing the WebSocket stuff. Because then, if the WebSocket has an error where it gets a sequence ID and it tries to put it in the open orders thing, I mean, who cares? We've already got it, that's fine. But if this one errors out, then we error out on every single order and we don't get to have any of them. So that's not really ideal. Although, let's test this real quick. A good test for that is if we comment this line out, there is now no WebSocket attached, and we should not be getting more data in here. So it should, and our count of how many open orders there are, instead of going up consistently like this just keeps going up because the WebSocket just keeps putting more orders in there, it should be one large number, and it would be however many orders we got from the HTTP call to this API endpoint. So hopefully this will be like 25,000 or so, and then it'll stay 25,000 or so 6 seconds later, or it will error. Did it really? Did you really error? How have you done that? What? So yeah, somehow you failed the unique constraint even without creating the WebSocket. That doesn't sound right. So I'm just gonna hit the stop button up here. Just keep hitting it because apparently there's a test still running. Not really sure what's going on there, but run it again, see what happens. And it should be clearing the database too, right? Before we get to downloading the order book. So these should all be empty tables. Which is why this unique constraint failure is a little concerning or confusing to me. All right, we ran, we exist, we did an error out, no unique Unique failure. Oh, just one. Huh. Failed open order sequence. Oh no, that's right. These are all gonna have the same sequence. Huh. Which is a super failure of the primary key. Right. Okay. So what we've got to do is we obviously need a different primary key for our open orders table, which is not a problem. We can just use the order ID, which is a more appropriate primary key for that table. So this error is caused by my kind of forgetting how pulling in from the HTTP side of things works. So when you're pulling in from the WebSocket, each new order is going to be a new sequence number because it's a new action. But when you're pulling the data that's already there, it just gives you the most recent sequence. So even if you were actually receiving those orders in real time, they'd be given different sequence numbers. Since you're just receiving this block of data, it just gives you one sequence number, which is going to violate our primary key. So that's not good. And let's make this just column info instead and change order ID to be the primary key. And then that should keep everything fine. Holy cow, if you control B on that, this code that it generates for you has a lot of uses in it. So let's see, we create one here and we always give it an order ID. Okay, so that should fix that error. Let's see how we do. And we might have to fix that elsewhere too, but I think it's okay because I think open orders is the only thing we're really bringing down in a big chunk. So it's the only thing that's going to have a sequence number that relates to more than one thing, meaning it makes a really bad primary key. So let's get Logcat here. Check in with the app, which built 10 seconds ago, is not running though. Okay, we'll just try it again. That's fine. And while that's running, I'll see if there's any questions over in chat. Jonas asks if I can explain a socket. Sure. So socket is like a persistent connection to something. Oh, and this didn't run again. Room cannot verify the data integrity. Okay, so real quick before I talk about sockets, this is another cool thing about Room. It tells you when you make a change but don't update the version number, it's like, hey, you've changed something, update the version number. So really clear error with that. You head into your app database class, you hit this version number, and you make it go up by 1, and then you run it again. And so a WebSocket is a persistent data connection with some service out there. So you can think of it just like a data pipe. So we're connecting to GDAX's pipe of data, and it just continually feeds us data. And for reasons that I really can't explain that well, it's just more efficient than using HTTP calls. So HTTP calls would be, I tell you I need something, you give it to me. And then if you wanted to do that continuously, it'd be kind of annoying, right? You'd have to keep telling them to give it to you and then just keep doing this back and forth all over. But with a WebSocket, you can just say, just keep feeding me this data, just pipe it straight in, and that's what you get. So you're basically just setting up a data pipe to just run data continuously at you, which is nice. And they do ask you to use the WebSocket instead of continually polling the API as well. So it's also a way for them to keep their API feed or their API access available to everybody who wants to use it. So the people who really need the data to be kind of drink from the fire hose style, they can use a WebSocket. And so we don't clog up the API. All right, so that ran, right? And it worked. Yep, no errors. Remember, it's normal to see this as empty because we start by clearing the database. So it's going to start with an empty trade history. And sometimes it takes a little bit to get a trade in there. Not really sure why, it just does. All right, Logcat, jump to the bottom. Okay, so 25,140. Not sure what's going on here. How are those even getting added? Let's message parser. We can, where do we create this message parser? Jump to that. All right, so we'll log a message as well when we receive messages. So we'll see if we're receiving messages, which I don't think we should be, because this should not be being created. My WebSocket. Wait, what? What is this class? Lifecycle adapter. So this gets created behind the scenes. That's interesting. Oh, and it does this for us. Okay. So the WebSocket's not receiving anything, and yet our order book is getting bigger. What the heck is running? And why does it not just say 25,000? Okay, we're not showing any errors, so we say download order book retrieved, adding open orders. Then so val, so let's just insert. We're gonna log the word insert and then the event, which is an open order, which is a data class, which means it's gonna print nice and pretty for us. So it'll print out all this stuff really nice, like Control Z, whatever I did there. And so we will see if those are getting imported. And let's put it after the actual insert. That way, if anything weird is going on with the insert, this won't run and it'll be really obvious to us that it didn't run. Because we should see that many insert statements, which is going to make my computer have a fit, but that's okay. All right, so that's gonna run. And let's get this to the bottom. All right, here we go. Insert forever. Same sequence, order, bunch of null times, and you can see some of these. Were there some times in there that weren't null? Yeah, what are you doing? How did we get a not null time in there? The heck did that come from? Must be logging something else, actually. Another log statement sneaking up in there. So does this just take forever to load these all in? Is maybe that it? Like it doesn't finish this and it's like in another thread? Is it another thread? No, it shouldn't be in another thread. Yeah, so that's definitely all of them. I mean, this is way more than we've been seeing. So this is definitely working. And got a bunch of different sides over there. Everything looks cool. And if we highlight here, we can kind of stop at some spot and scroll around and see what these ones in the middle are. So yeah, this is it. Kind of picking up slowly. Oh, so maybe that is just, it just takes that long to insert? Really? How do we insert these all at once then? Huh. So if it takes forever to insert, if we put a log down here, done inserting, is that, and we take, let's not take that one out, let's just comment it out. So maybe this should be not, I guess we might wait for that to get done. Well, and then it'll be after that. So yeah, since this is technically in another thread, then this code is technically in another thread. So perhaps inserting does just take a really long time, which we're about to find out. ROL asks, what is the name of the program you're using and is it available to Windows? It's called Android Studio, and it is by the Android team at Google, and it's how they recommend you make Android apps, and really just kind of how everybody makes Android apps. So Android Studio can be found online, and it's a really good tool. It's a kind of a flavor of IntelliJ IDEA. So IntelliJ are some people who make a lot of programming IDEs, and Android Studio builds off of that to make an Android specific one that's really good. And all right, let's look at the logcat. Jump to the bottom. Adding open orders. And right, so okay, that's exactly what's happening. This is going on in a separate thread, and it's taking forever to insert these. How does it take? So it can only insert like 200 rows every 5 seconds? All right, let's, we need a better solution from Room for that. Let's see what we got. So Room, insert all Android, because none of those words are super Android specific. Right, because SQL is built for handling tons of data. So if Room can't insert quickly, we've got a problem. Insert. Insert method. Insert its parameters into the database. Okay, let's try that one then. So for open orders DAO, let's jump into you, jump into your actual self, and insert, we want open orders, and we'll use this ... stuff. Wait a minute. Oh, what is the word for that? Kotlin multiple params. I had that word. That word is on the tip of my tongue. There's a varargs, that's what it is. Kotlin varargs. Vararg. Allowing a variable number of arguments to be passed to the function. Now wait, can we pass in an array, or does it really have to be like a comma delimited list of things? I would think that would accept an array. So actually it looks like it will just accept an array. So if we can get this into a list maybe? Okay, all of the parameters of the insert method must either be classes annotated with entity or collections arrays of it. So okay, we just got to turn it into a collection first. That's not too hard. So get rid of this. Actually, would we need another insert function? Yeah, let's leave this insert function and then add another. Actually add insert orders, open orders. Yep, okay, so we're gonna use that instead. And then we need to get this as a list. So let's get orders. Open orders is a mutable list of open orders. Yeah, I guess. Yep, that. And then is equals a mutable list of, which sets it to an empty list. And then we can set open orders. I guess we can just do it on a new line. orders.add event. Okay. And then we have that as a list, which is a collection. I believe mutable list would extend from list, would extend from maybe collection, or maybe there's another step in between, not sure. But so we'll do db.openOrders.insert orders, and then here let's try passing in open orders. Okay. And then we've got our done inserting call, so let's see what that does. Because SQL can certainly handle inserting 25,000 things at one time very quickly. And I mean, even if Android has poor performance, it should be under 5 seconds for the whole thing. No way it should take this long. So that's, I suppose, on me for inserting them one at a time instead of batch style. But that should work. And just checking out chat, yeah, Kotlin is awesome and definitely the future of Android programming, or the current, because they recently announced Kotlin as an officially supported language on the Android platform, which is awesome. And I'm using I think a 2015 MacBook Pro for programming right now, though at home I use a Linux desktop, and I also have used Windows computers in the past. So you can really use or program Android wherever you want. It's nice that way. Aha! We did it. So cool. There it is, 25,108, starts right off the bat. Perfect. Small problem, we did call this twice. So order book retrieved, download order book was called one time. Order book retrieved was called one time. Adding open orders was called twice. Nope, that's normal. That's cool. Because we did the buys and the sells. Okay. And then they both got added like that. So we get 25,000 buys, 17,000 sells. Put them together, we've got a 42,000 row database. Boom. Then we need to pull them in as well with, so let's come into main activity, comment out our WebSocket and see what that does. Then it'll start updating these with more data as the WebSocket rolls in. And then I think that'll be a pretty good stopping point for today because we're about out of time. But let's get this ran. Let's make sure we're in a good spot to finish out the UI side of things next week, which will leave us, and it's just got dark. It looks like it's about to storm here. But okay, that ran. We got download order book. Oh, right, that's right. So this is what the messages look like from the WebSocket. So if you weren't here for that part of the programming, and there we failed our SQL constraints, so we stopped. Like I mentioned, what happened. You can see just the messages just keep coming. That's what the WebSocket does. So since we can't look at anything there, we can turn that off right here. So definitely keep that off, close that. That all looks fine. And if we look at the app, it should running, there's the trade history. Here's the order book. So again, this order book is not showing the actual order book right now. It's just ordering these by the top 10, the best top 10 asks and the top 10 bids, and it is matching them together. And look at that, that's actually really good. 201, and there's a 500 right there. So we're a little behind because we're not updating anything yet. We've just finished pulling in data from the API call, and we're also getting it from the WebSocket and getting it together. And then right here, we're just showing the 10 best asks and the 10 best bids. But what we're not doing is updating any of this. So see this 199.97 order? That order is gone. It has been removed. It's either been traded into, that person's removed the order, or something else has happened to it, and we have not reflected that change yet. So that's what we'll be working on next week, is just kind of combining all of these data pieces that we have to get this outcome. So For the quick recap on how that works before I sign off, we've got the big chunk of data, the order book. Every single order that's on the book when we turn on the app comes in as one package right when we start the app as an API call. And we're going to insert all of those orders into the open order table. Then we also have the WebSocket, which pulls in different messages. It pulls in received, open, done, match, and change messages. And what we have to do then is handle each of these messages. When we get these messages, we're going to need to check. So for example, if we get a match message, we want to check and see if either of these order IDs is on our order book. And if it is, we're going to have to change that order. So for example, if somebody has an order on there and they get a match, we might need to, oh, it's pouring down right now. We will need to pull that order off of the book. And that's what we're not doing. So this order still here when it should have been gone a long time ago. And we might need to update this red color to be, or our block size to be maybe, so right now the max block, the point at where it becomes full red is 80. So we might need to change that number to something else. Actually, let's do that really quick. Let's change it to 200. It's a very arbitrary number, but that's okay. And we do that in trade history adapter, 80, 200, 200, all right. Okay, we've got this, which recall this lets us insert more than one order at a time and was the key to getting us past this error where when we did one order at a time, it just took too long. It would take minutes to insert all 25,000 orders, which is way, way, way too long. So yeah, next week we will figure out a way to pull this data out and, well, not pull it out, we already are pulling it out. We'll figure out a way to combine all of these different, all this data that we're getting from the WebSocket to actually update the order book to keep it in check with what's going on over here. And one last check to see if there's any questions. ROL asks, but to make Apple apps, will you need to have an Apple device? I'm not sure. I know there's a simulator, so you can kind of do what I'm doing here with it running like this, but you do, I think you do have to have like a MacBook to make Apple apps. So you do need, or like a Hackintosh or, you know, something else kind of like that. But I'm not really clear on that. I have never made an Apple app. I'm just an Android guy. All right, so next week we'll figure this out. Made some good progress this week. I'll commit this stuff here in just a second, but until then, see y'all next time.